All right, welcome back to another installment of Mr. P Helps with Algebra. This is Unit 2, Topic 2, Lesson number 9, which is about looking at functions and determining if they are increasing or decreasing at an exponential rate or a linear rate. All right, so we've got two different linear functions for each problem. One is called f of x and the other one is called g of x. F of x is the blue one here and g of x is the red one. And we're asked which one is moving at a quicker rate. Quicker rate means it's going up faster, and f of x you can clearly see is going up more. So if you think of these as a hill, it'd be harder to travel up the blue hill than the red hill because it's going up quicker. So each second it's going up more. This one, even though the red is above the blue, that doesn't matter. The blue is still going up faster. The h of x is actually not going up at all. So, by the way, the answer here was f of x. The answer here is d of x. D of x is increasing at a faster rate. Red, in this case, is the m of x. That one's increasing at a faster rate because it's going up faster. These two look similar. They look like they're parallel, but they're not. They're closer. S and x and r and x are getting closer and closer and closer and closer together, which means they are not going at the same rate. And the r of x is actually the one catching up to the s of x. So if we were to continue this graph further, sooner or later, r of x would actually surpass s of x because it's going up at a slightly, ever so slightly, faster rate. All right, pretty quick and easy warm-up, and this lesson is actually a pretty good lesson as well because we're going to be determining if it's linear, exponential, or neither. Linear, remember, is an arithmetic sequence, meaning it's equal differences over equal intervals. Exponential functions are equal factors over equal intervals, meaning it's multiplication, it's a geometric sequence, and neither would be anything else that's not one or the other, or could be both if we are given that possibility, which we'll talk about in a moment. All right, so this one is a straight line. That is equal differences over equal intervals. So as this line is going equally to the right, it is going equally down. So it has a common difference. All right, this one is, so that's linear. This one is exponential because you can clearly see the numbers are getting half as big. There are 4 players remaining after 5 rounds. Yep, and then after the 6th round, there'd only be 2 players because it's going 1/2 times 64 to the power of x minus 1. Yeah, I know that was the actual x. I don't need the equation, but I'm going to write, I could have written that anyway. This one is in y equals mx plus b format. Anytime you have a number multiplied by x plus or minus something, that's the y-intercept, that's going to be a linear equation. That means for every x, the y is increasing by 4. That's really what that means. This function is increasing at a constant rate. Well, decreasing, I'm sorry, I said increasing. That actually could be either because both linears and exponentials can both decrease at a constant rate. So exponentials would decrease if they have what's called exponential decay, which means you're multiplying by anything less than 1, but also greater than 0. And it's increasing if you're multiplying by something that is greater than 1. So that could be exponential, and it could be decreasing if it's linear because that means it's adding a negative number. So this is actually can't be determined. It can actually be both because they both can decrease and both increase. All right, so this one is increasing plus 1 plus 1 plus 1. That seems tricky, but why isn't it a straight line? Because it's not equal intervals. So if you look here, this is 1 difference, and this one is 3 difference. And this one is 1, 2, 3, 4, 5 block difference. So even though they're going up by 1, which is true, it does have an arithmetic sequence, but it's not over equal intervals. So therefore, that's neither. A person's height is a function of a person's age. Well, a person's height does not change at a constant rate, so it's going to be neither as well. You grow a lot more when you're a baby than you do when you're an adult, or let's say a teenager. This question, now, this is something that we're going to be doing in the future, which is setting the equation equal to y, which is changing this into slope-intercept form. So if I'm going to do that, I want to get y by itself. So I'm going to subtract 7 from both sides, subtraction property of equality. That gives me negative 3x minus 7 equals 4y. Divide both sides by 4 because I want to get y by itself. And that gives me y equals, I'm going to flip it around. Hopefully you can follow me what I'm doing. I'm going to put the y on the left-hand side and put this answer on the right-hand side. Negative 3/4 x minus 7 over 4. So that is linear equation. That's the starting point, and that's how much it's increasing per x. Linear. This one, let's see, equal intervals, yes, looks equal, so plus 2, plus 2, plus 3, plus 2, good. And this is minus 17, minus, ooh, that looks like 18 there. Oh, was it 18 the whole time? Yes, it is, it's 18. So minus 18, minus 18, minus 18, minus 18. So that is a linear equation. That's equal differences over equal intervals. This one, that looks very similar to what we just did. Do I have 2 pages of the exact same thing? Yes, I do. All right, so we already talked about that. So just a quick look at when you're going to have your next quiz. So we're done with this. We have a quiz coming up, quiz 7. We don't have our next tests until all the way down here. So just to look at all the things that we've done in this Unit 2, Topic 2. And your homework. You and your friends go to Wheaton Jolly Fair. It costs you $5 to get into the fair and $3 each time you go onto the ride. So I'm going to go to the equation. You can actually go anywhere you want first. I'm going to go to the equation. It costs you $5 to get in and $3 each time you ride a ride. So if Y represents the total amount of money you spent equals $5 you paid to get in plus the $3 for riding each ride. So if you're going to ride 0 rides, you would still have to pay $5. If you ride 1 ride, you'd have to pay $8 total. 2 rides, it's plus 3, plus 3, plus 3. This is an arithmetic sequence and so forth. So you can continue the pattern, 3, 4, 5, 6. This would be 14, 17, 20, 23. All right, and then if I'm going to graph it, I'm going to make this a 1-quadrant graph. These are going by ones. That's fine. That works. 1, 2, 3, 4, 5. And then every term after it's going to be an increase of 3. Next term, 1, 2, 3. Next term, 1, 2, 3. Okay, so maybe I shouldn't have spaced it out the way I did. There's my equation. All right. Thanks for watching. Please give this video a like if I helped you learn something, and subscribe if you haven't done so already. Look, I kept it pretty short. All right, thanks for watching. Have a good day.